3.6 linear inequalities. So we are going to sketch the graphs of inequalities and solve linear inequalities in one variable. So here are some rules that we need to remember about bounded intervals. Bounded means that they are contained. So we could have a notation of a bracket of a comma b, close the bracket. That is called a closed interval. Means that when we look at the inequality, it's a less than or equal to x, which is less than or equal to b. And we would graph it in this instance with a graph line with brackets on both ends, meaning the values are being contained within it and included. If you see parentheses involved as parentheses a comma b, close the parentheses, that is called an open statement. So in Algebra 1, you would have used a closed circle and an open circle. So normally our inequality would be a less than x less than b, and notice that when you graph it, it's parentheses on both ends, or you would have had two open holes on both ends, and it looks like a little dumbbell. You can also have a combination of a closed side with an open side. So in this instance, a bracket on a and a parentheses on b means the a value is included in the solution, the b is not. Or you could have the a in parentheses and the b with a closed bracket, which means the a is not included in your solution, but b is. You can also have unbounded intervals. Unbounded intervals means that the graph line is continuous. It's going to go to positive and negative infinity. So here in this example notation, it's a bracket of a comma positive infinity. It's not considered an interval type because it is going to an infinite value. So we look here, it says x is greater than or equal to a, means all the values of x are going to be bigger than the a value, and a could be any number. So it's going to be a bracket or a closed circle headed to the right to positive infinity. If you have parentheses on both ends, parentheses of a comma infinity close parentheses, that is known as an open statement, which means the values of x are bigger than they. They don't include the value of a, they are all going to be greater than a. So that's why it's called an open statement. Same thing when it's going negative infinity. So it's going to be parentheses on the negative infinity side, b is closed, means all the values of x are going to be less than or equal to b. Why the graph line is going to have a bracket at b and it's going to go towards the left to negative infinity. Again, it can become open when it's parentheses of negative infinity comma b, close the parentheses, means all the values of x are less than b, not including the value of b. If, for in some instance, your solution comes out to be negative infinity comma positive infinity, this is known as the entire line. You are going to have a graph line that points both directions, to the left, negative side, and right, positive side. So let's look at our first problem. In example 3, they're saying x plus 6 is less than 9. Think of the inequality symbol, the less than symbol. It could be a less than, a greater than, less than equal to, greater than equal to. Think of it as the equal sign. You're going to treat it just like if you're solving any equal equation. So we need to isolate the x, so we're going to subtract 6 over. To get x is less than positive 3. So let's look at all possibilities. It says x is less than 3, so I know that I'm going to be, there is no line, so it's excluded. It's an open statement. The graph is going, since the arrow is not pointing to the x, the arrow is pointing to the left. This arrow tip points to the left, means it's going to negative infinity. So when we go to graph it, here's 0, here's 3 to start. You can use a parentheses, and it's going to negative infinity. To write it as interval notation, notice that it says x is less than 3, and we said we are going to negative infinity. Negative infinity is on the left, so parentheses negative infinity, comma 3. Because there was no line to include it, you are also a parentheses. If you're going to write it in set builder, set builder notation is going to use the answer that you got, x less than 3. So you're going to do the face or the brace piece. And because the variable is x, it's going to be x, a line to represent x if and only if, and write your answer, x less than 3, close the brace. and that would be your set builder notation. In example 4, it says 8 minus 3x less than or equal to 20. So before we even start the problem, I noticed that there's a line, so we are going to be considered closed. It's great to identify what they need. So first thing, I need to subtract 8 over. So become negative 3x less than or equal to $20, and I spent 8. I still have 12. Now, here's the problem. You are dividing by a negative number. So the rules that we learned back in Algebra 1 said that when you divide an inequality by a negative number attached to the variable, you change the direction. So the arrow tip was pointing to the left. The arrow tip now goes to the right. So 20 divided by negative 3 is negative 4. So now it says all the values of x, instead of being less than this, now it says all the values of x are greater than or equal to negative 4. So if we do set builder, x, if and only if x is greater than or equal to negative 4. If we go to interval notation, because when we look at our graph line, here's 0, here's negative 4. You don't have to put every single piece. We're including the value of negative 4. So you have a bracket at negative 4 and it's going to the right. So set builder means bracket for your interval is going to be a bracket at negative 4, comma, infinity with a parentheses. That would be your interval notation. So we have our interval notation, and the one down here is your set builder. When we look at example 5, it says 7x minus 3 greater than 3 parentheses x plus 1, close the parentheses. So in a problem like this, think of back up to your order of operations, GEMDAS. Grouping symbols have to be broken out. So first thing we're going to do is distribute. So we get 7x minus 3 greater than 3 and x is 3x. 3 and 1 is positive 3. Now, because we're inequalities, all variables should always move to the left side. So we are subtracting our 3x back. So you get 4x minus 3 greater than 3. We are adding our 3 over. So we get 4x greater than 6. We are dividing both sides by 4. X is greater than 6 1/4. 6/4 is reducible. They're both positive whole numbers and even, so 3/2. Yes, it's okay to have fractions as an answer. So notice that we have a no line underneath, so we are considered open. So set builder is going to be x if and only if x is greater than 3/2. Define your interval, graph the equation. Here's 0, here's 3/2. All the values of x are going to be greater than the values. The arrow is pointing to the right. That arrow tip's not pointing to the value, it's pointing to the right side. So we are at a parentheses at 3/2 going to positive infinity. So parentheses, 3/2, comma, infinity, close the parentheses. In example 6, this is known as a combination inequality, which means think of an airplane. The inside is considered the middle of the plane. The left and right are considered the wings of a plane. Or this is a cruise ship. The stern, the forward of the ship and the back of the ship. So in order to balance the ship and the plane, you have to do everything to both sides. All 3 pieces have to receive the same thing. So the first thing we need to know is move from the inside out. So we need to add 2 to the left and the right. So become, I'm short 7 but found 2, I'm short 5, less than or equal to 5x, less than 8 plus the 2, I'm at 10. Now the same thing, I need to isolate that x. So we're dividing the middle by 5, the left by 5, and the right by 5. So -5 and 5 makes it -1. Our inequality slides down. The 5's in the middle cancel, leaving you x. Inequality comes down. 10 divided by 5 is a 2. So now notice this is contained, which means our graph, when we graph it, is bounded by -1 and 2. So when we look at our graph line, here's -1, here's 0, here's 2. It says -1 is less than or equal to, so there's a bracket at -1, comma, 2, there is no line, so I'm on parentheses, there is my interval notation. So a bracket at -1, parentheses, at 2, and they connect. When you put set builder, it's a variable x, if and only if -1 is less than or equal to x, less than 2, close your brace. Example 7 is another compound inequality, only a little bit different because this is known as an OR statement. So these are also known as your union statements. So you have two separate equations, and what we're going to do is solve each one individually, but graph them on the same number line to find our solution. So first thing we need to do is subtract both sides by -6. So we get -3x is less than or equal to, I had $2 but spent 6, I'm short -4. Now I'm dividing both sides by a negative number. So our inequality, instead of pointing to the left, is now going to switch directions, going to the right. So we get x greater than or equal to, -9 makes it +4/3. Our OR statement sliding down. Then we go to the next equation. It says -3x plus 6 greater than or equal to 7. So again, on this one, we're subtracting 6 to both sides. So get -3x greater than or equal to 7 minus 6 is our +1. Again, we are dividing by a negative, so our direction changes. The inequality was pointing to the right, now it's pointing to the left. So we get x less than or equal to -1/3. To find out what our interval notation is, our set builder notation is, we need to first graph it on a number line. So here's 0, 4/3 is somewhere here on the number line, -1/3 is on the other side, so I'm going to say it's about there. Remember, it's relative, doesn't have to be exact. Okay, on the first one it says all the values of x are going to be bigger than, greater than, or equal to 4/3. So we are a bracket at -4/3, and the arrow is pointing to the right, so it's going to the right, to positive infinity. So we have a bracket at 4/3 going to infinity. On the second one, it says x is less than or equal to -1/3. So at -1/3, we also have a bracket, but the arrow is pointing to the left, to negative infinity. So we have a bracket at -1/3, comma, and because it's negative infinity, had to be the first part. The last part of the problem is because we have a break in our graph. There's a break in our graph. This is called the union statement. So you need to have a U symbol between the two. You need to have a U symbol between the two. So this is your interval notation, this entire thing.